Tonight is June the 1st in the year 2022. I'm going to take you down into my basement where all the stuff is I like to play with and show you. What I'm going to focus on here is an AM transmitter. But I just thought I'd show you and document for posterity some of my junk down through here. Got a few dummy loads right there. Everybody needs a bunch of dummy loads, right? Extra oscilloscopes. There's a big one right under there. It's a little dark. Don't mean for it to be. A bunch of other stuff that I'll probably never use again. Anyway, and the kitty box. A little fan blowing in here. Wires. Ever ham radio operator or audio guy or whatever, audio person, guys, gals, needs a lot of wires. I also like chemistry. Haven't done too much of it yet. I made a bunch of rockets. Most of them out of potassium nitrate and sugar. Some of them have been very successful, some have not. There's a big antenna tuner, a little bit of overkill, and some audio stuff. Sorry I didn't get all lights on, but I wanted you to kind of, let's turn some lights on here. Some stuff I've made videos of. Gorgeous little Williamson stereo amp with Acrosound transformers. There's videos of it. Some other Heathkit stuff down here with 807s in it. Power supply I had to build. I bought this at an estate sale for practically nothing, but it didn't come with a power supply. I had to build that. Some other whatevers. A little Fisher. This is called a 70A. Wow, it's a magnificent little amplifier. Little Dynaco. Some whatever. This is a homebrew 4CX1000 amplifier. I ran it for over 30 years. Still works. Just got to slide a chassis in. Another antenna tuner. Antenna tuners are okay. They don't hurt anything, and they make the transmitter really happy. Here is the amplifier that really, this is the sane amplifier to have. A little Collins 30L1. Very compact. Runs 4 811s in it. They all need to have their power supply rebuilt, capacitors. Not a big deal. Here's an amplifier that I never have finished. It was, it started out, well, it's supposed to be, maybe one day it will be, a single-ended stereo. This is one channel over here, this is one channel over here, and it's choke loaded. The reason these UTC transformers are on there is to match the high impedance to the speaker. This is a power transformer for it. This thing is massive. That thing right there is, you won't believe how much it weighs. Here's a gorgeous little quad 1625. 1625s are the same thing as 807, but they got a 12 volt fill on. This was one of my first modulators when I decided to go AM again. I ran a kilowatt AM station back in the early 70s in Huntsville, Alabama. Some stuff that I built years ago before we come out with all this digital stuff that we all love so much. What have you? My family, my loved ones from the family that have long passed. I've even got a CB radio up here that works actually quite well. It does 7 to 8 watts of real AM. And if I could get some crystals for it, I would actually put it on 10 meters. But it works pretty good on CB. Got a little power mic on it and everything. I've made this thing work. There's another Dynaco ST70. A little dark in here, I know, but we're going to light the place up. Let me turn on some lights here. That's actually quite nice little amplifier. Some more oscilloscopes. Radiation meters, civil defense stuff. There's a gorgeous one back here that's a scintillator. I'm not going to open it up. There's some more general radio impedance bridges and what have you in there. We're about to get there. Here's an amplifier I built. In fact, right after I got married in 1977. Come on, focus now. It's an exact duplicate copy of a Macintosh MA230 channel. I needed it for a center channel back then. I've used it in a bunch of videos I've made. It just performs exceptionally well. Rated at 30 watts. It performs perfectly at 40 watts and above. Here's a little monitor I've rebuilt. Works very nice. I keep all of my stuff working. My stuff works because I keep it working. Oh, meters, what have you. A little roll around cart with some general tools in it. I hope I'm not boring you to death, but we're going to get there in a minute. Hang on with me. We're getting there. I'm going to power up here in just a second. Let's turn on some lights. Monitor, because I have recording cameras all over my house. It's mostly outside, only one inside. A little PC. There's where one of my kitty cats can sleep. I'm a kitty cat person. These are some solid state rectifiers that replace the, what is that, 872s? Big mercury vapor rectifiers you're going to see here in a minute. And of course some kitty morsels and little amplifiers that will operate up into the gigahertz range. Okay, but what all of this is going to be about is this AM transmitter right here. I'm encouraging people to build your own AM transmitter. There's a real movement nowadays for AM transmitters, for AM, transmission, and I've heard it called ancient modulation, I've heard it called advanced modulation, and I've heard it called angel modulation. Well, I'm going to tell you, I get reports that are just magnificent reports. Let's start powering some stuff up, and I'll show you what I do. You got to be creative. Let's power up this little guy right here. This is the IC736, beautiful little transmitter from the 1990s. If you notice, I got it in CW mode for whatever. You'll understand in a minute. Turn on our frequency monitor. Let's turn on our fan. Let's turn on our keep alive voltage back there. See this thing come up in just a second when the R tube here lights up. See it come up there? Okay, now we got voltage. We'll power everything up. We're not going to be using this one right now. This is a 1947 Collins 310B transmitter, exciter. Here's a front-end RF amplifier. Here's a gorgeous old Collins R390. It's the old version, not the R390A. This is a James Millen amplifier. It runs a pair of push-pull 812s down in there. I'm not going to pull it out. Here's the modulator for it. This is the AM transmitter. It runs a pair of push-pull iMac 4-125s. And here's the power supply for the amplifier, for the transmitter amplifier, for the RF amplifier. This power supply right here provides high voltage to this device right here. The modulator right here has its own power supply. I don't know how well you can see back there in the back, but there's a huge transformer back there, a 2000 volt 700 milliamp transformer. This transformer right here is extremely unique. It's out of an old World War II BC 610 transmitter. Not everybody knows what that is anymore, but quite an exceptional piece. And here is the speech amplifier for it. Let's see, I gotta turn the power on down here for it, and we'll flip it on. This is a rebuild, component for component correct, of an old Collins KW1. Runs original probably late 1940s 6B4G directly heated cathode output tubes, push pull. Here's the output transformer back here in the back. It's a power transformer. There's a little Mac amplifier down there that I used at one time for it, but I don't need it anymore. I don't use that anymore, really. Let's turn on a little bit of light here. Here's a frequency standard I use when I really want to know, when I want to sync things together so that I can punch in the frequency I want and I can hear it on my receiver. And a beautiful little spectrum analyzer. It goes up into the gigahertz range that I use whenever. Some microphones. These are actually cheap microphones. This thing's like 25 bucks or something. It works great. This one down here is an expensive one of 100 bucks, and that's what I use. Oh, coils. When you operate this old stuff, like this amplifier right here, you have to slide it out a little bit, and you have to change the coils in it. You have to change the plate tank coil, this guy right here. This one's for 40 meters, and you have to change the input coil, which is this one. Now this one right here is the one that plugs in to this guy right here. So I have to change 3 coils every time I change bands, and I have to make absolutely certain that the high voltage is off, and I always jumper the high voltage to ground with some little wire. It doesn't have to be a huge wire. It doesn't have to be the, you know, number 10 wire, but you need to jumper the high voltage to ground to make sure that you live through the experience in case you make a mistake. And back to my chemistry stuff, I have lots of scales of different orders and what have you. Here's some more of those plug-in coils right there. This is for 80 meters, I believe. Which ones, I don't remember anymore. Bird, line, section, watt meters, etc. I've shown this before. This is rather unique. I've had this for quite a few years. This is the digital readout. This right here is the digital readout for a bird line section. It's the digital readout version of this, which I think everybody is pretty familiar with. What I use that I've had for 40 years, that I built way back when, in 83 I believe it was. It wasn't not quite 40 years, it was 39 years ago, is this little peak reading RF watt meter. It does not discriminate between forward and revert and reflected power, so you need to have a very good load on the end, like a very low SWR, or it'll end up reading the sum of the the forward and reflected power. But I keep my antennas well trimmed and with a low SWR. Personally, I like to talk about return loss better than SWR because it's just in decibels. It's very simple. That would warrant an entire video to talk about return loss versus SWR, so we won't get into that. Here's a 1,000 watt bird dummy load with a meter on the front that I load things into before I load it into my antenna, so I don't I cause as little QRM as possible. I use this beautiful little Collins antenna tuner for 40 meters. Gorgeous little thing, isn't it? Works great. Don't have to have it, but it's kind of nice to have. Now here's something that has worked out really well for me. Well, first of all, there's my antenna rotor, of course. I run a single band, a mono band, 20 meter hex beam. Why mono band? Because that's what I want. But I have this switch setup is really a good idea. This switch lets me select the 20 meter antenna, the 40 meter antenna, or the dummy load. And this switch right up here lets me select the receiver transmitter, the rig that I'm going to run. If I put it in the Collins SLine, I got to put that one down. Then I run my SLine stuff. This is my AM rig. This is my 833. I'll show you that in a minute. This is the 3400Z. This is the KWM2A and the 30S1. So right here, if I put it on 30S1 and I put this on 40 meters, I'm switching my rig here and I'm switching the antenna there. It just works great. But we're going to do the AM rig and we're going to do 20 meters. Here's a little amplifier built a number of years ago. Runs a single 3400Z. It'll do 500-600 watts on all the bands. It uses a B&W 850A plate tank coil, which you can sort of see in there. I'm very hooked on vacuum capacitors. So all of my rigs run vacuum capacitors. This is a beauty right here. I love this guy. This is an 833A. Let's turn this guy on. See, I got it light up. Big red spot runs in the middle of it. You can see a lot of these pictures on my QRZ page of WA4QGA if you're interested. I run these 866As mercury vapor rectifiers and a voltage doubler. Now I know that's not recommended, and I don't care if it's recommended or not. I've been running it like this for years and it works great. What I mean by it's not recommended is actually, I think you can see the filaments lit in there. You're not supposed to run the output of a mercury vapor rectifier into a capacitor filter. But if you're going to run a voltage doubler, it has to be a capacitor filter. And then here's where I switch to different high voltage levels. It's off right now, and then this enables it. If this switch is down right here, if this switch is down right here, then it just bypasses the amplifier and the exciter goes straight through it. Here's the input tuner that I made a video of just by itself. Call it Ultra Trans Match or something like that. It really works good. Really good design. An ARRL article on it from 1970. And the way that I get high power into my basement to run the 120 volt stuff is I run 240 volts to the basement, and then I use these different size 2-to-1 transformers. I step 240 volts down to 120, and that works really good. Really does. It's a really good idea. I have another one in the big transmitter over here. I'll show you in a minute. And there just happen to be some big capacitors sitting here on the floor. What are these things rated at? 6 microfarads to 6,000 volts. You always want to keep high voltage capacitors shorted like that with a piece of wire, because these things will build up a charge across them without being shorted. I can't show you that right now, but I have verified it to myself more than one time. These things, if they sit around for, I don't know, if they sit around for a day or a week or a month or a decade, don't know the number, but I guess the static can build up in them. These things can build up a charge, and of several hundred volts, no doubt. And when you short the two together, pow, you get a pop out of it. So you don't want to get surprised. You want to keep high voltage capacitors like this, especially these really high-end capacitors like this. These are made by, I think, what do they call them? By plastic. They're made by Plastic Capacitors Incorporated. Been around a long time, and just good stuff. Good stuff. This is the Collins 30K1 transmitter. At the moment, it's the one that had that 4CX1000 in it for quite some time, but now it has a pair of 4400s. I run some IMAX in there. I run some Pentalabs. Actually, Pentalab makes one, I believe, I don't want to make a mistake here, but I think they're called PL175s, which are actually pentodes. They're not tetrodes. And you have to have those little ground fingers on there to ground that ring right there. But if you run those genuine Pentalab pentodes, the third grid is connected to that ring, because there's not enough pins on the bottom to connect it to another pin on the bottom, and you have to ground that, and they work great. And this is my beauty stuff. This is a Collins 51S1. my KWM2A, my SLine equipment. I do operate my SLine equipment in transceiver mode, where the VFO of the 75S3 controls the transmitter. The light is not burnt out in there because you can turn it on right there. But that puts the VFO in the transmitter in control if you remove the jumper wires. But I leave it right there in what they call receiver VFO mode. This is for people that are not really familiar with the SLine stuff. And then this operates as a transceiver. So I only have to turn one knob here to change frequency, and my transmitter, my receiver up here, VFO, is controlling the transmitter frequency. Now I do have to do the loading. It's a little tedious. Power supplies are down here. They still run vacuum tubes in it, and they work great. Here's a little Elecraft W2 LED type watt meter. And of course, here's a crown jewel, the old Collins 30S1. We'll take a quick look at the inside. I do have solid state rectifiers in there instead of 3B28s or 866s. Massive transmitter, massive amplifier. Runs a 4CX1000 in the final. Sounds very good. It has no compression. It has no processing of speech, and people love it. You know, there's a lot of signals out on the air that sound really good, and there's some that sound really bad. And overdoing the speech processing and the compression is not a good thing. It doesn't make you sound better. These are old D104 microphones, except the elements in them. This one right here is actually still original D104 element inside. It still works. The vast majority of the original ceramic elements have gone bad. But you can replace this element right here with a 69-cent condenser microphone element inside. You take it apart, and then you have to have one of these that's got the, I can't touch it with my finger here, but you see it's got the volume control there. It's got a 9-volt battery in there too. You do have to provide a voltage for the condenser type microphones. These old speakers up here just sound great. That's an old Hammerlin speaker over there. This is something that some old ham built many years ago. Sounds good. It's got a 500 ohm to a 4 ohm transformer in it, because the outputs of these types of receivers here, or a lot of them are, most of them have both. I think this has 500 and 4 ohms, and I think the KWM2A has 500 and 4 ohms. You might notice it's a Rockwell Collins too. It's not the winged emblem, and it's not the meatball emblem, as some people call it. Well, we're kind of powered up in here right now. I've got to get situated just a little bit more, and then I want to show you the details of the AM transmitter. If you want to go AM, you want to go all the way. I can't encourage anybody to build their own like this, because this power supply down here is 1250 volts. The voltage in the modulator is 2000. They'll all kill you. This power supply feeds voltage to this amplifier. This modulator has its power supply built into it. You do not have to run it that way. You can run a single power supply if your single power supply will provide the proper voltages for your modulator and your amplifier at the same time. But that was not my case. That was not what I wanted to do. And the reason I didn't want to do that is because I needed to match the proper impedance of these two modulator tubes through this transformer to the proper driving impedance on the secondary of this transformer to this amplifier. See, the impedance on the primary side, the modulator side of the transformer, is different than the impedance on the secondary side to the RF amplifier. Basically what happens is this right here is nothing but a very large audio amplifier. And the voltage from this power supply down here that feeds this device right here runs through the secondary of this transformer up to here. And as far as that DC value goes, there's really no change from here to here to here. It's straight through. It's like a wire. But when you start modulating this, it adds and subtracts from that voltage coming from here through here to here. This modulation is this modulator is modulating this voltage that's going up here. But to make it efficient, you want to make sure that this transformer primary matches these tubes, the primary side of it, and you want to make sure that the secondary side of it matches the impedance of the RF amplifier. And this RF amplifier, this modulator right here is driven by that little speech amplifier right there. And right here is where the microphone plugs in, which is this microphone right there. So the microphone plugs into the speech amplifier. The output of the speech amplifier, which is not plugged in right now, is actually this wire right here. And it will be in just a minute. And it plugs in right there in that plug right there. And that's how I get the driving signal from the speech amplifier where the microphone plugs in. This amplifies it a little bit. This amplifies my microphone up, and then it runs through this wire, which will be plugged in right here. And it's enough audio, it's about 5 watts, to drive these tubes right here, which will increase the power to, at least 200 watts to drive this guy right here. And that's the way an AM transmitter works. I'll go over that again because I'm not sure everybody understands that. Be right back just in a couple of seconds. Okay, I think I'm going to do this once more because I want to go over what an AM transmitter really is. Here's the microphone, of course, that we speak into, the microphone input right here, or the output of the microphone. Actually, it goes through this little guy right here, which is a phantom voltage power supply, as you can see right there. And the reason it goes through the phantom voltage power supply is because this microphone is a condenser mic, and a condenser mic has a field effect transistor amplifier built into the microphone itself, so it requires a voltage. Now, if you're using older microphones like ceramic mics, crystal mics, or even dynamic mics, you don't need the phantom voltage device down here. But the condenser mics of today are very, very good, and they're actually quite cheap. This is a $100 microphone, and that's an expensive one, really. You can get it for a whole lot less than 20 bucks. Okay, the output of this microphone ultimately plugs in right there where it says standard mic. I got one here that says Collins PTT for push to talk in case I want to use that. Here's my microphone gain, and it has a clipper circuit in it. The clipper circuit is basically not used. It has a 12A-U7, that's a 12A-X7, a 6A-L5, that's a dual diode, and a 12A-U7, and that was really cool stuff back in 1955. That was modern day stuff. See there? And it drove and drives now a pair of genuine 6B4Gs. I sent these 2 tubes right here to my friend in Poland, and because of some screw ups in FedEx and what have you, they wouldn't give them to him without a mordita. You'll have to look that up if you don't know what a mordita is. It means a bite, without paying more. So they ended up sending them back to me. So these things went to Poland and back. Uses a 5V4 rectifier back there. I got a standard little multi-section capacitor in it. There's the output transformer right back there, and there's the power transformer. Okay, so the microphone goes in here, got a microphone gain in a clipper level, and then the output of this device right here comes out of this little purple wire, and I was showing just a second ago, plugs into right here. So the output of this little speech amplifier right here is developed at 4 or 5 watts, very little power. The amplifier is capable of much more than that, I think about 15 watts. But I don't need all of it. Well, actually it says right here, I only need 2 watts. Okay? It doesn't take much power because these tubes right here are running class AB2. Now these tubes right here running class AB2 with 2,000 volts on them, and I don't remember what the screen voltage is and what the bias voltage is, that one right there that's kind of flickering. It says like 47, 48 volts. Can you see it blinking back there? Those are little cheap meters you can get off of eBay. I like to know what my voltages are. But anyway, these tubes are running class AB2 and they need a certain impedance on this side, on the primary side of the modulation transformer. A modulation transformer is the same thing as an output transformer in a hi-fi amplifier, except the secondary impedance on a modulation transformer is high. It's not 4, 8, or 16 ohms. It's like 4,000 ohms. It's the only difference. Okay, so you need to carefully match the impedance that these 2 tubes want to the primary so that the secondary output matches the load that the transmitter amplifier wants. I got to slide this out just a little bit so you can see these beautiful 812s in there. An 812 is a low mu triode. An 811 is a high mu triode. An 811 has a mu, which means the gain of 160. I think the gain of an 812 is like 30 or 40. Low mu triodes make very good Class C high level plate modulated RF amplifiers. Look it up. You'll see this. If you're really interested, you'll figure all this out. Okay? So what you have to do is you have to know where you're coming from and where you're going. Well, what happens is this power supply down here, which is not on right now, of course. There's a voltmeter there that measures from 0 to 2,500 volts. This power supply right here, when initiated, I'll enable it here. This won't turn it on, this will just enable it. See that light come on? It means now it can be turned on. And I love signs like that. You know why I put those signs on there? So I won't kill myself. And hopefully no one else. No one else is looking at it. They just think it's cool. I'm putting it on there for me. And the best sign of all is this one right here. Death on contact. That's what'll happen if you get across it. Okay? This is not a joke. These things are not your friends. They will kill you. Okay. The voltage from this power supply right here simply goes up through a wire into the secondary of this transformer right here. Goes through the secondary, and then it goes from the output of the secondary straight up to this amplifier right here. Well, when there's no audio being developed here onto the primary, then there is no audio being superimposed on that direct current going through the transformer. So for all practical purposes, this transformer is a straight wire. Yes, it has a little bit of resistance in it, but it's insignificant. Well, when you start modulating this thing by putting a couple of watts into it, and this thing starts developing a lot of power, then the primary starts developing a lot of power, and it starts adding and subtracting algebraically, plus and minus. As the signal from here goes positive in a sine wave, it adds to the voltage. As it goes negative, it subtracts from the voltage. Well, when the voltage if this is 2000 right here, that's not what it is, 1250, but let's suppose it's 2000. When the voltage here is 2000, then it adds together, and now it's 4000. And when it goes on the negative cycle and it's negative 2000, the voltage on this side is 0. If this is 2000 and you add plus 2000 to it, you get 4000. If you add minus 2000 to it, you get 0. That's called modulation. You are modulating the DC voltage coming from this power supply through the secondary of this transformer that feeds DC to this amplifier right here. And as you modulate this, plus and minus, it either adds and subtracts from that 2000 volts. At 100% modulation, it'll be 4000. Positive. At 100% modulation, negative, it'll be 0. Well, here's the funny thing about it. Now here's where the rubber meets the road and separates the men from the boys, as they say. You can modulate it a lot more than 100% positive, but you cannot modulate it not even one tiny bit more than 100% negative. Because if you do, it will shut the carrier off. And when you shut the carrier off, then all kinds of terrible things happen. So you need a monitor like this. See, this one says percent modulation negative peaks. This one says percent modulation positive peaks. You could modulate it as much as you want positive, but you never ever want to modulate it more than 100% negative, because you shut the carrier off. You pinch the carrier off, and when you pinch the carrier off and it goes off and it turns back on abruptly, then you get what's called splatter. Not a very descriptive term, splatter, but that's actually what it's called. And it's not good. It causes a lot of trouble on both sides of the transmitting frequency that you're on. So you want to prevent that at all costs. Okay? All right. Let's power this thing up and kind of watch what it does. Okay. We are on the air into a dummy load. See our dummy load there? Here's our watt meter, just a little over 300 watts of carrier. You can actually see me talking right there a little bit on the meter because I'm at a distance from the microphone. We are into a dummy load. The way that I've got it hooked up over here is I've got my AM transmitter selected right there into the dummy. Okay, so we're not bothering anybody. There's our transmit frequency, 14.243 megahertz. Here's what we call a keep alive voltage. This is a low voltage. I've got it set to maybe like 75 volts. That keeps the negative modulation from never being shut off, because it never actually allows the transmitter to go to 0. And it also requires this circuit right here. Now, there's deadly voltages on all of this, so I can't stick my hand in any there. All this stuff is alive and doing very well. Okay? But what's happening right now is the high voltage from this guy right here. See those beautiful mercury vapor rectifiers? They are on. Our plate voltage is just shy of 1300 volts. That 1300 volts right there is going through the secondary of this transformer right here up to this amplifier right here. Well, to tune one of these types of amplifiers, you peak the grid. This is the grid circuit tuning over here. You peak the grid right here. Watch, I'm going to see how you want that to go as high as it'll go. And then this is the plate circuit right here. And I used a resonance circuit tuner over here, and I want this to go as low as it'll go. You peak the grid and dip the plate. Now, peaking the grid and dipping the plate is a term back in the 60s and before that is as simple as hot's on the left, cold's on the right. Shit runs downhill and payday's on Friday. And if you don't know that, well, I don't know what you don't know. Sorry I had to go there. But that's the way it is, okay? Now, we're modulating this thing, and I'm going to put this microphone here in front of my mouth. And watch this right here. If you'll notice, the left meter never can go. It is limited. It is limited by this little power supply right here called the keep alive voltage that will never let the negative voltage to the final amplifier, which is those push-pull 812As, the RF amplifier, will never let it go to 0. But you can see on the right side that the louder I talk, you see it punches up to 120, 130, 130 volts, whatever. You want at least 100% modulation on just about everything you say. And you can see that I'm getting that. You can also see that here on the peak reading RF watt meter, because we're into a perfect load. So we're not getting any error here of the sum of the forward and the reflected voltage. And it's peaking up at about 1125 watts. So even legally, by the FCC standards, we're not exceeding the 1500 watt PEP level. And we're putting full modulation, as can be seen right there, but we're never pinching the RF carrier off. If you pinch the RF carrier off, you sound terrible. And I hear AM stations on 80 meters that just sound horrible. Excuse me, guys, but clean up your act. Okay? That is an AM transmitter. That is a real AM transmitter. A power supply here going through the modulation transformer to the RF amplifier. Now you don't see a lot of movement in the plate current meter, you don't see any in the grid current. And this kind of washes out the camera here, but as I speak I can actually see a slight flaring up of the orange in the output tubes. I don't know if you can see it here or not. I think the camera's a little overloaded and washed out. There's the modulation current on the modulator. And it's all coming from here. It's coming from this microphone input, being modulated by that 12AX7, limited by the 6AL5, the 12AU7 drive, and the 6B4Gs. The output of that coming through this little purple cable over to the input of the modulator, driving these two tubes. These two tubes are driving the primary of this transformer. The output, the secondary of this transformer has the DC voltage from this power supply right here running through it, providing DC to this RF amplifier right here, which is being modulated by my voice superimposed on that DC voltage by this modulator. That is an AM transmitter. And you know what else? I'm going to put this thing down, turn it off. Puts out a lot of heat. If you're going to run AM like this, you've got to have some pretty big components. Now, if you've got a single sideband transmitter that'll do 100 watts of single sideband, it'll probably do about 25 watts of AM. That's good. That's fine. There's nothing wrong with that. I'm not against any of that. This is not anybody's better than anybody else. But high-level plate modulation is the best. Nobody can dispute that. But if you're going to run high-level plate modulation, you've got to have big components. You've got to have components that can get hot and that can take the heat. And if they can't take the heat, well, they're just going to burn up. And in the solid-state devices of today that run AM, they have to run at low power, because the average power, not the RMS power, there's no such thing as RMS power. That was something concocted back in the late 60s, early 70s to sell stereo amplifiers, and it has stuck around forever. There is no such thing as RMS power. It's called average power. That's another video on itself, again, to explain that. But anyway, there it is. There is an AM transmitter in its, I think, most beautiful and raw form. Now here's an old receiver made by Collins back in about 1955 or so, called an R390. It was an AM receiver. It will receive single sideband because it does have a BFO. Not many people even, I mean, some of the new hams I don't think know what a BFO is. It's called a beat frequency oscillator. It's the frequency that you mix with the internal parts of the receiver so that you could receive single sideband. Nowadays we call it RIT, incremental receiver tuning, or whatever it stands for. RIT, receiver incremental tuning. Yeah, it's a digital thing, but this is an analog thing. So I don't want to get off on too much of a tangent there. But that's an AM transmitter for them. It's got to be kind of big. It's got to be heavy. You know, this power supply down here probably weighs 70 or 80 pounds. This one weighs a little bit more than that. This one's not too heavy. This one weighs another 85 pounds. So if you just kind of average it out at 80 pounds, it's 240. So the whole shebang weighs, you know, 300 something pounds. Well, this guy right here, this thing's made out of steel. I think it weighs about 300 pounds. 300 pounds may not sound like much, but when you're trying to move that kind of dead weight around, it's pretty massive. All of my amplifiers are very heavy. I started with my general ticket in 1963 when I was 13. I was born in late 1949. I've been on 59 years. I'm 72 now. I don't know how much longer I'll make it. And I do these kind of videos not because this is better than anything or anybody or what have you, but it is definitely except for very few people, it's definitely a lost art, but I think it's still much appreciated. And when I get on and I have QSOs with guys, I'm overwhelmed at the response I get from them. I'm just overwhelmed with how they complement the quality of the audio. So if you want to go AM, here's what I'm going to say to some of these guys that I just criticized a while ago. If you want to go AM, you want to be the best. And if you aren't the best, then don't do it. Just stay single sideband and be happy. Single sideband is more efficient. There's no doubt about it. But AM has got a quality to it that, I mean, it's the hi-fi version of ham radio. And if you don't want to do it right, then, you know, why bother? There's a lot of single sideband stations. I'm going to say it again. I said it a while ago. This is a critique of it, but there's some bunch of AM single sideband stations on that I hear that are horrible. You want a full range of voice audio frequencies. You don't want to try to sound like an FM stereo station, because if you put too many lows in it, then you just sound kind of muffled, and you sound kind of like that, and nobody can really understand you unless they're just like really busting their ears to hear what you're saying. You don't want that. You don't want to sound like that because your meters are, you know, banging on the right side of the scale, and you think you're a really big dog because you're just, you know, pumping out massive amounts of power, because you may sound terrible. You want people to understand what you're saying. You may not have much to say, kind of like what I'm doing right now. I may not have much to say, but whatever you got to say, you want people to understand and appreciate it, and hopefully find some value in it. So thank you, ladies and gentlemen of YouTube, for indulging me and watching my videos. I invite you to stay with me and be safe, and hopefully we'll meet again someday.